theory of deep formation, the history of science without history, by Olayinka, Oladele, Oludotun, Awopetu, Professor of Applied Manufacturing Technology, Machine Tools and Cutting Tools. In line with the tradition of our university, this inaugural lecture will be presided over by our Vice Chancellor, the very first female Vice Chancellor of this institution, Professor Oladele, Fellow Academy of Science, and Vice Chancellor and welcome. We also have other principal officers of the university in our midst. Professor Timothy Taiwo Amos is the Deputy Vice Chancellor and then the Deputy Vice Chancellor of Development, Professor Sunday Samuel Oludotun. We also have Mr. Charles Oladele, our registrar. Abosa is Minister of National Peter Oshaduka. You are welcome, sir. We have the University Librarian, Dr. Robert Awopetu, and the Acting Provost, College of Health Sciences, Professor Oludotun. I would also like to use my handset to recognize and welcome our deans from our various schools, led by the Chairman Committee of Deans and Deans of Computing, Professor Boniface Kayode Adeshi. Professor Oladele Thomas Adebayo is the Dean of Agriculture and Agricultural Technology. Professor Akim Oladele, Dean of Basic Medical Sciences. Professor Christopher Oludotun is the Dean of Infrastructure, Minerals and Manufacturing Engineering. The Dean of Electrical Systems Engineering is Professor Oladele. Professor Awopetu is the Dean of Health and Mineral Sciences, while Professor Joseph is the Dean of Environmental Technology. Professor Olayinka is the Dean of Logistics and Innovation Technology. Professor Dean of Life Sciences. Professor Dean of Physical Sciences. Professor Oludotun, Dean of Postgraduate Studies. And Professor David Olayinka, Dean Students Affairs Division. And also today, let me introduce the inaugural lecturer, Professor Olayinka Oladele Oludotun, Awopetu. Shall we put our hands together for the inaugural? Right now, I would like to invite our Vice Chancellor, Professor Oladele, for our address. Our Vice Chancellor.
Thank you. The Deputy Vice Chancellor, Academic, the Deputy Vice Chancellor of Development, the Registrar, the University Librarian, the Bursar, my lords, spiritual and temporal, top government functionaries, here present, the inaugural lecturer of today, Professor Olayinka Oladele Awopetu, deans, directors, and heads of department, especially the Dean of Infrastructure, Minerals and Materials Engineering, and the head of department of Industrial and Production Engineering. Distinguished members of Senate and Congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. I welcome you with great pleasure to the 184th inaugural lecture of the Federal University of Technology. I warmly welcome our spiritual and traditional leaders, top government functionaries, captains of the inaugural lecturer to please rise while I present the citation. Olayinka Oladele Awopetu was born on the 1st of April 1963 in Ibadan, Oyo State. He had his secondary education at Christ School at Olayinka in 1980, attended University, titled Mental Coding and Theory of Teach Formation, the history of a science without history. Please join me as I welcome Professor Olayinka Oladele Awopetu. Thank you.
Vice Chancellor, Deputy Vice Chancellors, the Registrar, other principal officers, deans and directors, distinguished professors and serving members, heads of department of units, royal fathers, spiritual leaders and guests, gentlemen of the press, distinguished ladies and gentlemen, great gratitude to God Almighty for the privilege, favor, and grace, mercy to deliver the 184th inaugural lecture on the topic Mental Coding and Theory of Teach Formation, the history of the science without history. The topic was derived from where do we go from here to better reflect the fundamental problems of mental activity and provide insight into how and why we arrived at our present state. This lecture is designed in the Department of Industrial Engineering and offshore of Mechanical Engineering, where it will have been the 7th. It is also the 26th School of Engineering and Technology and second in the School of Infrastructure, Materials and Manufacturing Engineering Civil. To be sincere, I was never biased to be an engineer, and I've always acknowledged this fact. In the job form I took in 1980, I was to study physics, mathematics, combined course at the University of Ghana. If my results of biology with help, I will be delivering this lecture in the School of Sciences. The only saving grace was that I had my papers in GC 1979 November 7. So I picked up the admission for at Oludotun, electrical and electricity department. That was my department of choice. My results were released in December and sorry, mechanical engineering department that was spent without closing of the admissions. And the then lady said I was too lazy to be a mechanical engineer. Ironically, if not for chemistry, I would not be there. I hated that subject with passion when I was in school. But the teacher, one Mr. Oladele, intervened and through the connection of one of my friends, Mr. Oladele took special interest in me, guiding me patiently and encouraging me to develop interest in chemistry. This friend of mine is no other person but the immediate past governor of the state. His Excellency, Dr. John Kyle, who had last year's he was an equal to Mr. Oladele. Your Excellency, I remain sincerely grateful for your also necessary intervention back in 1977. It was as if it was so a better life for me in science rather than arts. After completing my national diploma in 1982, I graduated from 1 year from Moscow University of Italy. I first worked as a mathematics teacher at Japan High School, and later on, I gained employment at the Calcutta State College in mid-1983. Remarkably, it took me 21 years from primary 1 in 1968 to my master's in 1989. And a journey of 3 years supposedly took me 23 years. The only reason that anybody told me was that I was too blunt and unspoken. I must confess, I don't think I have changed anything. Madam Vice Chancellor, when you are the first time I go to my regular lecture, it's a formal academic event where a newly appointed professor presents research and opportunity to wider community. Today I take into the world of metaphors and theory of transformation. A science with profound impact, yet often without its proper historical recognition. Subtitled, The History of the Science Without History. Challenging us to reflect on this paradox. Meta-plotting surrounds our daily existence. From the moment you woke up this morning, you've interacted with countless machine components, from household equipment to every other thing that you are owning. Behind all this lies the controlled and precise removal of material through cutting, a process that defines our world. The practice of metal cutting is as old as civilization itself. Early humans shaped gold and copper with stone, while Bronze Age introduced us to stronger alloys and more durable implements. Over centuries, innovations such as today, milling machines and the CNC system revolutionized machining with higher precisions and automation. Paul Beck, in 1961, described this transition as the shift from art to sciences. He traced the root of metal cutting back 600,000 to 1 million years ago to Africa, specifically Tanganyika, now in Tanzania, where humankind first fashioned cutting implements. This reminds us that Africa once led the world in technology, and with renewed focus, we can still rise again. The precision required in engineering components is accurate. Tolerances of microns ensure smooth operation, safety, durability. Without advanced cutting, neither internal combustion engines or the electric motor could exist the way we know them today. Thus, metal cutting is not simply a mere manufacturing method. It is the foundation of industrial civilization, silently shaping the tools, machines, and devices that power and connect our world. For all its pervasive influence, the science of metal cutting and chip formation remains an unsung narrative. Unlike Newton with gravity, Einstein with relativity, we do not often celebrate the names behind breakthroughs in machinery. There are no popular documentaries or biographies dedicated to this intellectual journey of this process. Yet, for over a century, engineers, physicists, material scientists have studied the complexity of chip formation. Their work has always been driven by industrial law, that is, cutting faster, extending the tool life, improving the surface finishing, rather than philosophical recognition. As a result, the focus has been on results rather than the intellectual history, making it truly a science without history. Why study chip formation? Chip formation occurs when cutting tooling reduces plastic deformation and sharing of the workpiece material. Once stresses exceed the yield strength, the material separates along shear plane and forms a chip. This process depends on the workpiece material, the properties, the cutting tool geometry, and cutting condition. But why devote so much attention to something as small as chip? The answer lies in 5 imperatives that govern manufacturing processes. 1. Efficiency. 2. Quality. 3. True life. 4. Energy consumption. And 5. Cutting process. To appreciate the meanings of chief formation, we must define key terms and conditions. Metal cutting is the controlled removal of material to achieve a desired geometry. Regardless of operation, with it turning, drilling, or milling, principles of chief formation are the same. Important parameters include cutting speed, feed rate, depth of cut. The factors influencing chief formation include the workpiece material, that is hardness, ductility, cutting through geometry, relief, and machine rigidity. For example, ductile metals like aluminum often form continuous chip, while brittle cast iron receive discontinuous chips. A historical paradox. Metal cutting, though central to industrial progress, lack a celebrated historical narrative seen in other sciences. While machine tool history is documented, and the gear design is also documented, they all boast of recognized milestones and biographies. Metal cutting's history is fragmented and often anonymous. Old works, such as Finn, 1956, and later Astrabov in 2006, reference only selected contributions. Many innovations came from workshops transmitted by apprentices rather than recorded in formal literature. Their autonomy and focus on output rather than the theory explain why the history of metal cutting remains elusive. Why is the history elusive? Several reasons obscure the history of metal cutting. For centuries, it was a craft passed through apprenticeship to non-academic writing. Innovators, blacksmiths, millwrights, machinists often remained anonymous. Emphasis was always on the product, not on the scientific process. Most importantly, is the industrial secrecy that kept these best practices hidden. Lack of analytical tools meant observations were qualitative, not quantitative. Many principles become common sense engineering, losing their origin. Thus, while other sciences boast well-known landmarks, metal cutting's intellectual journey was quietly embedded in workshops and factories. Early theories and discourse. Paul Black, 1961, noted that early attempts to explain chief formation appeared in the 19th century. Smith, 1870, 1877, proposed the shear as the basis of chief formation, while Tresca, 1873, believed in the compression of metal ahead of the tube. In truth, both were partly right. Plastic formation is achieved by shear, but shear itself is caused by compression. The absence of developed theory of engineering plasticity at the time led to the apparent contradictions. Later researchers such as Black in 1961, Astor in 1999 classified these principles. Emergence of scientific movements. The Industrial Revolution demanded precision and consistency. Spurring the scientific study of machinery, F.W. Taylor, with his empirical work, established relationship between cutting speed, tool life, and productivity, laying the groundwork for formal analysis. In the 20th century, the marching circle diagram and shear plane model provided the first systematic framework for understanding chief formation. These theories introduced key concepts such as shear angle, cutting forces, and energy partitioning in machinery. the role of shear angle. A critical parameter in chip formation is the shear angle, which directly affects chip thickness, cutting force, and power consumption. By analyzing shear mechanism, engineers can optimize cutting conditions, improve surface quality, and extend true life. Thus, understanding shear angle and chip mechanics is not just theoretical curiosity, it is vital for achieving efficient, predictable, and sustainable machine operation. Evolving science. Metal work has existed for millennia, yet scientific theory of metal cutting only matured in the 19th and 20th centuries. Since then, this field has continued to evolve with advances in high-speed machining, tool coatings, and even hybrid manufacturing methods. Metal cutting is both art and science, blending a tacit knowledge of blacksmiths and machinists with the analytical models of modern researchers. Its success is measured not by fanfare, but by the precision and efficiency of the components it produces. Today, we stand on centuries of accumulated knowledge, building an ever-advancing science that remains central to industrial civilization. The transition to formal science. By the end of the 19th century, Taylor brought systematic study to metal cutting, recording extensive data on true life and cutting speed. We could see the graph of true life, where the speed, cutting speed, true life are related. It laid the foundation for scientific study of chip formation, the origin of theory of chip formation, and assumed law. In the late 19th century, Russian scientists I.A. Smith and K.A. Svorsky proposed the assumed theory of chip formation. They viewed the process as plastic deformation of excess material along a single shear plane, although oversimplified. Chip formation was described in terms of depth of cut, chip thickness, cutting forces, rate angle, friction angle, just as shown in the diagram. Continuous chip formation was explained through shear force satisfying plastic deformation resistance, offering a first mechanical description of chip formation. The first theoretical theories, having exploited the empirical formation made by Maudslay, Whitford, and most notably Taylor, we now arrive at a pivotal moment in the history of metal cutting. Early 20th century research shifted from observation to explanation. The key concept introduced was shear plane, the narrow zone where primary plastic deformation occurs during cutting. This recognition marked the true birth of metal cutting theory, allowing researchers to begin quantifying forces and deformation mechanisms rather than relying on trial and error. Law of shear angle formation. The shear angle governs cutting forces and chip thickness. While theory suggests that the shear angle occurs at pi/4, in practice, the shear angle occurs at a portion less than pi/4, because the greater omega from the diagram, the smaller the shear angle. That is in practice. Larger values of omega will reduce shear angle, linking shear mechanism to geometry and friction, making shear angle prediction both scientific and practical importance. Marshall's theory of chip formation. In 1940, N.E. Merchant proposed a single shear plane, assuming a sharp, true, straight shear plane, uniform straight, and no post-shear deformation, using geometry. Merchant related the shear angle to the head angle and achieved weakness ratio. You can see all that he came up with. That was in 1940. Merchant's model introduced force and geometry relationship, but oversimplified deformation, ignored built-up edge, and assumed ideal material behavior despite its limits. It was still monumental step in machining theory. Lee and Schiffer's rigid plastic model of 1951. Lee and Schiffer built on the plasticity theory, modeled the workpiece as a rigid, perfectly plastic. They replaced Merchant theory, Merchant single shear plane, with distributed deformation using slip lines, just as it is shown. This approach captures stress equilibrium more realistically, but retained idealization. Together, Merchant's and Lee's theory define the early theoretical landscape of chip forming mechanisms. Chip shrinkage. This is actually where most of these laws are at times assumed. During cutting, chip thickness exceeds the depth of cut, while the length is shorter than the length of cut. This coefficient is known as the chip shrinkage. With that equation, chip velocity, the speed at which the speed moves, is also higher than the speed of cut. Thus, chip shrinkage connects deformation geometry with actual chip flow, linking shear angle with chip movement speed. Now we come to the real theory of chip formation. The anomalies in the assumed are worked on in the real theory, where later researches reveal that the chip deformation occurs along a single plane, not along a single plane, but within infinite shear zones between lines PL and KN in the diagram. There are multiple of shear planes that are oriented parallel to themselves, and it is the passing of this particle through all these planes that actually starts and ends chip formation. And that is why all the things, the speed of the chip being long and the length being shorter, works out. Using a built-up device and microstructural studies of chip units, researchers showed continuous deformation within this zone rather than instant transformation. This refined understanding aligned with physical laws and addressed earlier limitations of the assumed theories. We have the pictures of specimen for use, processed and unprocessed. The one to the left is the unprocessed, the one to the right is the processed. Continuous chip formation. Continuous chip formation forms during machining of structural materials, just as I have the picture there. We can see that the chip, which is towards our left, is much more different from the parent material. If we are machining a brittle metal, we have a discontinuous chip, just like in the sketch. The continuous chip with built-up edge. This is where scientists differ a lot. Most of the things that are in the textbooks are only explaining the built-up edge phenomenon in metal cutting, and definitely not continuous chips with built-up edge. So when chips should be classified as continuous chips with built-up edge, they are chips that look like intermediary between discontinuous chip and continuously, just like in the picture that we're looking at. They could also be referred to as serrated or segmented chips or cyclic chips. They come as chips elements, segments, continuously joined together. Their characteristics, semi-continuous, sawtooth appearance, mechanism, they are cyclic in nature. Now, the built-up edge phenomenon in metal cutting. Some chips are formed with built-up edge, appearing continuous with sawtooth. Built-up edge forms when workpiece material adheres to the cutting tool break face under intermediate speed and high friction. It alters the cutting geometry, increases wear, and causes poor finishing. Though sometimes providing temporary tool protection, chips with built-up edges represent an intermediate type, often difficult to machine. In its own case, it's not a type of chip. It is a phenomenon in metal cutting. You can see the built-up on top of the cutting tool in the diagram that we have. My contribution to the theory of metal cutting. Vice Chancellor. My journey to this area began in November 1989 with my first PhD at the Volgograd Polytechnic Institute, now Volgograd State Technical University, Russia. The work, optimization of type of cemented carbide tool and its geometrical evaluation for optimal turning of alpha titanium alloy 85 in a semi-finished turning operation. Required in-depth study of cyclic chip formation, cutting forces, and true workpiece contact. My second PhD, completed in FUTA between 2004 and 2012, was titled Development of an Electromechanical Device for Online Monitoring of Cutting Tool Wear on Lathe Machines. This research focused on overcoming the challenges of traditional tool wear monitoring and advancing online monitoring technologies. Relevance of tool wear monitoring. In today's advanced light-out manufacturing environment, the leading vulnerability remains the cutting tool. Traditional approaches to tool wear management, such as manual inspection, rigid replacement schedules, or reliance on failure detection after defects occur, are inefficient and costly. My contribution addresses these challenges through the development of an online monitoring system where tool wear is detected indirectly by measuring process signals such as cutting forces, power consumption, vibration, acoustic emission, and temperature. These indicators, much like medical vital signs, provide reliable, real-time information about tool health. My academic contribution. Since 1989, I have consistently engaged in teaching, research, and supervision at both of the parent and postgraduate levels in this specialized area of metal cutting and chip formation. The journey of more than 46 years has led to the supervision of over 100 research projects, 20 masters in engineering dissertation, and 4 doctoral processes. I also have published more than 40 journals in the reputable peer-reviewed journal furthering consultation authority in this area. Equipment were used for the experiments, like lathe machines, also materials, titanium. Different types of cutting tools were also used with different geometries just to find which one would be optimal. Research methodology. Experiments were conducted on both industrial and student machines depending on availability, and the analysis covered both rough and semi-finished turning operations. in rough turning of alpha titanium alloy, brittle wear dominated, while semi-finished turning wear was influenced by the microstructural characteristics of the alloys. My finding shows that recommendations in handbooks were often contradictory, with some suggesting identical cutting speeds for titanium alloys C51 for better titanium alloys BT15, regarded as extremely difficult to machine. Handbooks often recommend the same cutting speeds as for alpha plus beta alloys. This is the research setup. The workpiece on the lathe machine and the other gadgets attached to it. Discussion. Titanium as difficult to machine material. Titanium alloys are classified as difficult to machine materials, primarily due to their very low thermal conductivity. During cutting, the process of plastic deformation is adiabatic, meaning that the heat is concentrated on a small volume of the chip formation zone. This localized heating accelerates tool wear and necessitates frequent tool replacement even at relatively low cutting speeds, unlike machining of steel. Coolant penetration. Coolants are to help reduce the temperatures of the cutting process. They are sometimes referred to as lubricants. But the actual point where we want these coolants to get to lubricate, they don't get there. They are in the region of C2, zone of plastic contact, shown in the further left of the diagram. We use radioactive coolants to see the penetration. Even at that, the penetration did not reach that point where it was to be lubricated. So in any textbook, referring to coolant as lubricant during turning operation is absolutely wrong. It can only be possible if you are using, if it is like drilling, milling. But in turning, it is absolutely wrong. Microstructural effect on chip formation. The microstructural composition of the workpiece plays a significant role in chip formation. The fracture strip or line of maximum stress occur at plot boundaries, which are weakest regions against deformation. Larger structural blocks increase the stress required for deformation and broaden the chip formation. At the displacement stage, differential movement results in pot belly, the upper diagram you can see. The chip is coming out like a pot belly. Instability in shear zone arises when the orientation of microstructures causes deviation in shear speed rather than complicity. This is a graph of cutting forces while turning and the effect of the microstructure on it. The cutting forces come and go, they are high at a point and they are low at another point. True wear mechanism. My experiment revealed that while the cemented carbide tube BK6 resists clearance face wear, it is prone to microbricks on the brake face. BK8 performs better on the brake face but wears faster on the clearance face. BK10ON and BK10XON shows resistance to micro pull-ups but overall wear more quickly. T-thickness K6 fails almost immediately at the high speed, while T5K10 exhibits excellent wear resistance but suffers from excessive clearance wear. Durability tests showed that big cases lasted only 15 minutes at 60 meters per minute, but this could be extended to 40 minutes, though at a cost of productivity. Early two-year was characterized by micro breaks and pull-ups, and the enforcement factor was found to significantly improve through reliability. This is the graph of a cutting tool where before the introduction of the reinforcement. This is the graph of the pull-ups from the rate face of the cutting tool and the graph and corresponding graph to it. My findings. At this point when I was writing, I was tempted to ask for a change of my topic. To change the topic to metal cutting and theory of chief formation, a case of rejecting the message because of the messenger. In my case, at the end of it, it was written in the basic instructions before leaving the Bible. In the book of Psalms, chapter 23, most importantly, verses 5 and 6. With all sorts of verses. These results have since been published in peer-reviewed journals and as of today has never been challenged. If for more than 40 years, I have only been researching in this area of advanced manufacturing, machine tools and cutting tools, having resolved that I am proudly humbled to say I am an authority in this area, anytime, anywhere. With no sense of community, Mrs. Vice allow me to borrow a phrase and slightly modify it from one of the playlets that I participated in while in secondary school. This is our chance, whose author is James Henshaw. He says, "This is the child of my brain, the product of my endeavor, and the materialization of my inventive genius. Western science have not succeeded in getting this result that I have, but I, Olayinka, Awopetu." Vice Chancellor, my findings were first presented in 1993 at Prof. Polytechnic System, but they were rejected with a claim a black man cannot obtain such a result. The experiments were repeated for another 2 years under strict supervision, yielding identical results, which have since been published in the journals without challenge. These results called into question the universal acceptance of Magellan's shear plane theory, which was in 1945 as against being propounded in 1870 by Tine, a Russian, just because of geopolitical bias. My research contributed to validating alternative methods, particularly the thin chip formation zone in Catalonia. These two pictures, they show clearly. The one on the left is titanium, the one on the right is limestone. When limestone constantly deforms, titanium does not, which means the shear zone, which everybody has thought is always present, is not always present. It comes and goes depending on the material that you are cutting. In titanium alloys, the chip formation zone is very thin, and unlike a stainless steel, chip elements are not deformed during the formation. Awopetu and 2008 demonstrated that it is incorrect to generalize chip formation mechanism across all workpiece materials without considering their structural and structural properties. My discovery showed that when large structural blocks are favorably oriented, the cyclical process can disappear, leading to the formation of the continuous chip that significantly reduced true wear. This unique chip had not been previously observed. It was first published in 1993, largely because the high cost of titanium and limited experiments conducted by other scientists. This is the novel chip that was first presented to scientific world in 1993 and its corresponding oscillograph graph. Instability of the shear zone. Chips often move at speed higher than the cutting speed and exhibit greater hardness than materials. However, under certain structural conditions, the shear zone may temporarily disappear. Just as shown, to optimize cutting through geometry, it is necessary to promote blade face angle. We need to introduce the reinforcement facial, which my research introduced. The results show that tools with large negative angles suffer from rapid diffusion wear, reducing durability to 15 minutes, while my recommended geometry achieved a better balance. If we look at these two pictures, we will see clearly that both the chip structure and the parent structure, they are identical, meaning the chip did not pass through the zone of chip formation. In both cases, that is what you know in titanium, and that is what tells us that it is not right to say that zone of chip formation is always present, because it is not always present. Vice Chancellor, tools with positive geometry show less wear initially, but quickly recedes the critical point of 0.5, 0.7. By contrast, my recommended geometry extended durability to 30 minutes at cutting speed of 60 meters per minute, which is acceptable for industrial production. This has never been attained before. Positive two-ray also produce tight twisted chips that were difficult to remove, making them unsuited for practical applications. My recommended true geometry therefore provided the optimal combination of durability, chip control, and productivity. The graph you are seeing, the lower graphs, they are the graphs of the cutting through wear with my recommended geometry. As you can see, I was able to get up to 50 minutes, and the graph is still under 0.6 millimeters, whereas 0.7 is the optimum. These are results validated from experiments that actually you can turn titanium at speeds that are practically acceptable in practice. Acknowledgement. The Vice Chancellor, I have every reason to thank God Almighty for His unending protection, provision, mercy, grace, love, and favor for me from back up to today. Even with the assurance of tomorrow. How else will you speak, and what else will you say if something prevented your deaths after 2 attempted suicides within 3 months? I am his spoiled child because of the love he has for me. Let me still tell you something. In the year 2000, after 2 suicide attempts, following all my frustration in Russia, I like when Jacob fought with the angel in the book of Genesis, chapter 22, verse 24 to 29. I told him to either kill me right then or bless me right then. Not only that I am alive today, that signifies that he has decided to bless me, but 2 hours after, God himself solved the greatest financial problems of my life at that time. Since then, I have been moving from blessing to blessing. I give him all the glory. Acknowledgement to my parents and parents-in-laws. My parents, Mr. Oludotun and Mrs. Oludotun, did not live to witness today's event. They are highly appreciated for everything they did for me. As I know I was brought up with the knowledge that integrity is not the best option. It is simply the only option. For us in our family, as I earlier mentioned, I am so fortunate and favored to have been taught at every stage of my education by the very best, my modern-day father. Being my very first teacher, not only as a doctor, but as my primary one teacher in 1968. My mother was someone that loved me and I loved unconditionally. My parents are evangelists. Also at this point, can never be complete without me showing my parents' names. Mrs. Rima Yatsa, who died in 1997, and Mr. Vitali Yatsa, who just died 15 July 2025. These two people gave me their only child as a wife in 1993. I know God will give them this. And they have always been supportive. You are highly missed. My family, the person standing in the gap for my parents is Mrs. Oladele. This morning, she told me she could not come because we lost one of our siblings, and she's not feeling too comfortable today. She's not only my mother's younger sister. She is our second mother in the family. To us, when we say auntie, without any name, it is Auntie. Her late husband, Dr. Inaugural, and she owns the first nursing specialist hospital. They love and care for the mother, and the extension of the family is simply unconditional. Until I thank God for you that you are here to and seated for the issue and seated to witness for my father, your loving husband and your precious sister, my mother, this special relationship. She's of course represented here by his second child, Dr. Oladele, who is seated. My prayer is that God Almighty grant you many more years in the success of your message. I cannot but recognize the promoter of opportunity. It's where my majesty, my submit and never to Lord of promise to be here to witness this occasion of my living with 184 inaugural lecture of this great university. According to the future community. I came to future in 2002 February to NYC, and since then I've been under the leadership of 5 substantive vice chancellors and one acting vice chancellor. Second, at Prof, who actually employed me on temporary status in October 2002, before I finished my service, and I had to defer my resumption to the end of service in December 2002. After I came to Olayinka, who fished me out from nowhere and made me to be the executive of senior staff group, being the first elected true congregation. As if that was not enough, he also appointed me an associate director of Center, the State Association of Health Innovation Center in 2011. The center changed name to Center for Entrepreneurship in 2012, and I still retain the associate as the associate director. I held the position up to February 2019. He never acted as only the vice president to me, but he was still my big brother and of course very good friend. Thank you, sir. Professor Fashaki was acting as chancellor afterwards and also continued the friendship and brotherhood after Balogun. The turning point for better, however, came in 2012 with the inception of Professor Awopetu's administration. He not only continued the friendly relationship, but he also took it further to my family. Professor Gramana now means love my family and I unconditionally. To us, if you say this without mentioning the name, it is Professor Gramana. Egon, you are still being used, and I think that will be for a very long time to go. Continue to rest in the Lord. Professor, who have stepped into the saddle of leadership after the turbulent tenure of Professor in May 2017. Although I cannot boast of the tight relationship, personal relationship I had with him last week, but he was also a brother. I once told him in 2021, during a mini crisis on the campus, that if he thinks that we are not friends, his name will all be seen to mention anytime I'm delivering my inaugural lecture. I told him that either I like it or not. He announced me as an associate professor and announced me as a professor. So I have to mention his name. Either I like it or not, either he likes it or not. At the validatory service session of Professor Gramana, people were giving opinions on the PowerPoint. And I raised up my hand, I was about the last to be called. And I said, VC, ensure that people can talk like this about children you are also giving. You see that they have always been talking of how Gramana was promoting people. He just told to where I sat, said, Dog, you will be promoted. And he promoted him. Thank you, sir. Professor Awopetu came in 2022, and she still there. I thank God for leadership style. Around the campus, you have so many names. The only one I can say here is Oladele. Meaning, Oladele not just of light. I will privately tell any of you if you want to know others. Just pay me something. She has a lot of others, so I'm still wondering how you picked me to be the director of Television and Professionals. I thank God and you for successes there. As a community. First and foremost, I have to appreciate the grant. I was first a member of the Association before I went to national. If I had not been a member of Association branch, I would never have gone to national. So I thank Association branch for at least allowing me to be a member. I have been a member of the school since 2006, when I was elected as an assistant secretary. The list can go endless, so let me not make all this much. Everybody is important and I have to tell us, but I need to mention one or two names. A name that I will mention is the name of Professor Olayinka. Olayinka drove me to this inaugural lecture like a slave driver. We were announcing the same day. He had delivered his own sins, and we tell him, you can just start. Let's see how we can go about it. Just start. Here I want to do. One, I'm very good. Other names are there. I won a research grant from the Presidential Intervention Committee of Technology Transfer PSCT under Nasser. We get a grant of 257 million. We are still working on it. I thank the president of the chairman of the PSCT and the executive vice chairman of Nasser for it. We are still working on your 4 grants as we speak, and hopefully they will all come good. Between 1975 and 1980, I attended Christ School, the best school. That said, 75 are also the very best that anyone can pray for. You can imagine, for 45 years that we completed our secondary school education, and 50 years since we started it, we are still going together in everything. We'll be going back to our grade in October this year for another event. Among my classmates that have told us is the Excellency Dr. Carol Fire, the immediate past president of the state. Then the Ambassador Olayinka was promised to be airport. Has to change. The immediate past Comptroller General of Immigration, Mrs. Kangla Adekunle, who is our current president. Fire was our immediate past president. The list of others are also there. And I still need to mention somebody specifically. Oh, actually two. Roti and Shade Dams. I refer to them as the people that ask my remote button. They have the remote button they can use anyhow, but I thank God that they are using it as professors. They are not using it just anyhow. And thank you. I love you and your family. That one I'm sure you. I must acknowledge all staff of BBC, Future BBC, most especially the directors with me, Professor Banido in the press, Professor Diaz, General Services, Professor Bushi, International Scholars, and Mr. Olayinka, water. As I earlier said, I am a lady and professional. My siblings, I wish you would acknowledge my siblings here. Gratitude to Awopetu. His wife was Ibiroke Awopetu. Olabisi Akindele, her husband, Pastor Carol Akindele. Opeyemi Babatunde, his wife, Kayode Babatunde. Nige Ola, her husband, Debo Ola. Adeni Awopetu, Tole Babatunde, and his wife, Ife. Yes, we lost one. I thank God for making us siblings. My family. The past 3 years has been very, very, very full for my family. Some of us will know about it. But when we encountered one 2 months ago, 27th of June, we thought we had seen it all. We wanted to start moving and going together. Lo and behold, exactly 1 month today, my daughter, today, 100 level student of UI was kidnapped. But God showed himself. sent an angel in one Mr. Caravan to our rescue. What a God we serve. She's here to visit him. Thank you for keeping the room light, and I thank God for the life. Grateful to God for having me. My son, our King, he moved everything about his work to hear what we do. You have chosen your path, and God has chosen you. You never wanted to be under anybody's shadow. Never wanting to be dependent, or never wanting your independence to be undermined. Life may be hard. I may have been hard too. But remember that not only are you a man and you overcome, you are unconditional. Thank you for your understanding and objectivity. My daughter, Martina, she could not be here with my granddaughter, Jola, as she currently is working and residing outside the country. God sent a strong representative in my son-in-law, who is seated there. Maybe I don't say it often, but I thank God for the lady that has come to be, the wife and mother that she is become. I know I can be difficult sometimes. But you know you are always ever good. On the 7th of July, 1988, a girl walked into the hostel. She followed her friend. Without knowing her name, I approached her and I told her that you will be my wife. And I said her for the first time, I didn't know her name, I didn't know when we meet again. But lo and behold, on the 16th of October, 1993, she became my wife. My wife, and as I normally call her. Well, to majority, if not to every other person, you are Dr. Italian Awopetu. I want to tell you, in my own little way, I love and cherish you. I understand and appreciate your sacrifices, especially what you had to go through to be here today. Rushing back from the burial of your father in Rome, even while I am not there. Thank you. As you now can see, I am not weak. I am favored. Thank you for enduring me. I must also say I endure many of them. God bless you.
Thank you to the students. We thank Professor Awopetu for that well-delivered lecture. Distinguished ladies and gentlemen, it is customary for us to acknowledge some special people in our midst, and we may not be able to recognize all, but permit me to recognize first from within our own persons. Professor Oladele, the former Vice Chancellor of Redeemer University, Professor Oladele, thank you for coming. Recognized Professor Oladele, former Deputy Vice Chancellor of Academic Future, thank you sir for coming. Professor Tunde Arayena, former Deputy Vice Chancellor of Academic, also in Future. We recognize Professor Philip Oguntunde, former Deputy Vice Chancellor of Development Future. We are happy to also know that Dr. Ayomi Oludotun, the former registrar, is here with us. Thank you sir for always joining us. My friend and sister, Professor Dube Ajayi, thank you for coming. Despite the ceremony you had yesterday. We want to also acknowledge with thanks the presence of Mr. Richard Arifado, immediate past minister of Futa. He is there with his amiable wife. Thank you, Matt, and to Kike Lomo Arifado for joining us. We also have with us today a friend and sister, Professor Oladele and the former Nigerian Futa. Thank you, Matt. We also have in our midst the former dean of the School of Environmental Technology, Professor Oladele. Professor Oladele, thank you for joining us. We have with us Mrs. Zainab Falai, former Deputy Nigerian here in Futa. Distinguished ladies and gentlemen, we have with us the sixth pastor of the Living Faith Chapel, Akure Pastor Dapo. Thank you, Pastor, for joining us. Thank you, sir. We have with us Professor Michael Alatishi, the former dean of School of Engineering and Engineering Technology. Baba Alatishi, thank you, sir, as everyone fondly calls him. We have with us a former member of the Governing Council, Professor Fashion. Thank you, sir, for joining us. We have with us here today architect Kami Oladele, the MD and the CEO, Architect Project Limited. Thank you, architect, for joining us. We have with us the Vice President, Futa Alumni Worldwide, Mrs. Bukola Olasalawo, representing Futa Alumni Worldwide. Thank you, ma'am. We have with us Mrs. Olabisi Akedele. She is Permanent Secretary, Ministry of Chieftaincy Affairs, Ekiti State. Thank you, ma'am, for joining us. We are most grateful. We have with us Pastor Kayode Akindele. He is the former registrar with Redeemer University. Thank you for being with us again. You were with us in the course of last week. Thank you again for joining us. We have with us the ASU Zonal Coordinator, and he is representing the National President of ASU, Pastor Adiola Oludotun. Thank you, sir, Pastor Adiola. Okay, we have always, we have with us Dr. David Ashu, the past chairman, ASU Unilag. Thank you, Dr. Ashu, for joining us. I recognize the entire members of ASU Futa, ably led by Comrade Professor P.P. Magari. Thank you. ASU Futa, please rise for recognition. ASU Futa. Thank you all for being there. Part of us. Thank you. We have with us members of the Christ School 78/8. Also, where are you? Thank you. Also, for joining us. We also have with us members of the immediate family of the inaugural lecturer. We have Mr. Ademola Sadipe Adekunle, is the son-in-law to the inaugural lecturer. Thank you very much, sir, for joining us. We have Awopetu Akinta Philip, is the son of the inaugural lecturer. Thank you very much. We also have the daughter of the inaugural lecturer, Awopetu Oludotun. Thank you for joining us. We have with us a special guest that once visited somebody in the room where Professor Awopetu was looking in 1988. She eventually became the only woman that he loved in a little way. And he says in a little way that she is loved and she is cherished. No other person than Mrs. Anne Awopetu, the wife of the inaugural. Thank you, ma'am, for agreeing to marry the man that said he was not lucky but only forward. We thank you. And we have the most important groups of persons here in our midst today. Great Futerians. You are the most important and you are the best. Thank you for coming.
Thank you very much. A couple of announcements. All professors in the hall, except those from Siemens and Sesen, are to wait in the hall. Christ School, 7580 set to wait in the hall. ASU visitors to go to ASU Secretariat. Member of staff of IPE and MBE to go to the department. Oludotun indigenes in Akure to go to Professor Babadola's office, engineering building, while other guests are to wait at the foyer of the auditorium. Great Futerians, and we announce where we go after the exit of the Vice Chancellor's procession. Having come to the end of the inaugural lecture, shall we all rise for futal anthem and then the national anthem? Leads the auditorium in a reverse order.